Okay, physics. So I wanted to walk you through the connecting that we do between forces and kinematics. And really there's only one connector, and that's acceleration. So we use forces, and we use Newton's second law to find acceleration or no acceleration. And then acceleration is the connection that we use to go to the kinematics equations. All three of our kinematics equations contain acceleration, so you get to decide. So again, the key thing is recognizing the connector and then just mathing your way through it, so step by step. So let's look at two examples. So first example I wanted to look at was a block. Say we have a block that's being pulled along, so we'll assume some force. And we'll put some numbers against this. So let's say we have a force that the block's being pulled with, which is 10 newtons. And I'm getting some frictional force, which we'll figure out is 2 newtons. And the question is, if the mass of this is 1 kilogram, how far does this travel in 10 seconds? So notice, so we have unbalanced forces, so it's going to be accelerating. So we want to figure out, well, what is the acceleration this is experiencing? And once I know acceleration, I can figure out the distance that it's traveling from. So again, I'm going to assume it's starting from rest. So, all right, let's see what this looks like. Where'd it go? Okay. Yeah, so I've got a box. Draw a little force diagram. So my vertical forces are going to cancel, so I don't care about those. I'm going to have mg, normal force. I'm going to have a force that's being applied, and that's going to be 10 newtons. And I'm going to have a frictional force, and that's going to be 2 newtons going in the opposite direction. So what I'm going to worry about are forces in the direction of motion. So this is my direction of motion going left to right. So I'm going to use Newton's second law. Acceleration is the sum of the forces over the mass. And so this is the first step I'm going to do. So I'm going to work through with forces to get to acceleration. And then the second step, I'm going to use my kinematics equations, my motion equations, to figure out whatever the answer is I'm looking for. So how far did it go in 10 seconds? So they tell me a number of things. They tell me the mass is equal to 1.0 kilograms. And they tell me starting from rest. So I know my initial velocity is going to be 0. And I'll start my initial position is going to be 0. My final position I want to find, right? That's what I'm after. And they give me time is equal to 10 seconds. So notice that I have some things that are useful for kinematics equations. And the only place we use mass is in forces so far. So we don't use mass in any of our kinematics equations. Okay, so sum of the forces. Let me sum the forces up. So I'm going to decide this is the positive direction. So why not? So I'm going to have 10 positive and 2 negative. So my acceleration is going to be equal to 10 minus 2 divided by the mass, which is 1 kilogram. So I'm going to get an acceleration which is equal to 8 meters per second squared. Right, and that's my connector. That's going to take me to the other side. So I can use that to get a pen that works. Okay, so I'm going to use that over here. So let me list out what are the things that we know. Well, we know position is that we start with is 0. The position that I end with, that's what I want to get to. My initial velocity is going to be 0. My final velocity, I don't really want to care about it. I don't need to know it. The acceleration is going to be 8 meters per second squared, and the time is going to be 10 seconds. So I'm going to look in now I'm going to hunt for a kinematics equation, and the one that's going to work is the one that doesn't have final velocity, which is going to be this one. Oh man, I'm having pen crises. So it's going to be x naught. Whew. Okay, number 3. X naught plus v naught t plus 1/2 a t squared. What am I looking for? So I'm trying to get to the final position. So I don't need to rearrange anything. I plug in numbers. This is going to be 0. This is going to be 0. So I'm going to have 1/2 times acceleration times time squared. So it's going to be 4 times 100. So I'm going to get 400 meters for an answer. So that's one type of question. So again, using a connector between acceleration to get me from forces to kinematics equations. Okay, we do a different one. So let's see. Suppose I've given a box a push. So I gave it a push, but now I've stopped. So it's not experiencing a forward push, but it is experiencing friction. Right, so I'm going to give it some initial velocity. So initial velocity, I'm going to give this, say, 10 meters per second. Why not? I'm going to give this some mass. Let's give it 10 kilograms. And I give it a push, and I'm no longer applying any forces. It's going to experience friction, and it's going to slow down. And let's say it goes a distance of 30 meters. So my question is, so what is the coefficient of kinetic friction? So let me think backwards through this, right? So I only have one equation that has coefficients of friction in there. So this is my force of friction. My force of kinetic friction is going to be equal to my coefficient times the normal force. So I know mass, I can figure out normal force, but to find coefficient, I'd also need to know the force of friction. So this is my only force acting here, so I'm thinking, well, the only force, right? My acceleration is going to be the sum of the forces divided by the mass. Friction is my only force. That if I know acceleration with mass, I can get to that frictional force. With a frictional force and the normal force, I can get to the coefficient. So I want to do acceleration. So again, I have some kinetic information. Always the connector is going to be acceleration. So I'm going to find acceleration and work my way backwards. So step one here, let's figure out what acceleration is. So I'm given position. I'm going to say it starts at 0 and it ends at 30. My initial velocity is going to be 10 meters per second. Is coming to rest. So I'm going to say it goes to rest at 0 meters per second. I want to find acceleration and time. I don't want to deal with time. I don't want to know it. I don't care about it. So I'm going to look up an equation that doesn't have time, and I'm going to discover this one works well. So v squared is equal to v naught squared plus 2a delta x. So this is my kinematics equation that doesn't have time, the only one. So I'm going to plug stuff in to see what we get. Oh, for fun, I don't want to rearrange it. So what am I going to have? So this is going to go to 0. So I'm going to have v naught squared is equal to negative 2a delta x. I want to get to acceleration, so I'm going to divide both sides by minus 2 delta x. So my acceleration is going to be v naught squared over 2 delta x, and it'd be negative, right? It should make sense, right? So by default, I've said this direction is positive. I gave a positive velocity in that direction. My force needs to be positive in that direction too, right? So I have to use the same positive axes. And if it's slowing down, acceleration needs to be going in the opposite direction. Well, now I have something for acceleration. I could plug in and get numbers for that, but not yet. So now I'm going to use forces. Now I'm going to go to forces. And I know my connection between acceleration and forces is Newton's second law. And I'll draw a free body diagram for this. So what's happening here? Well, I'm going to have my weight and my normal force, and those two are going to be equal and opposite. It's not accelerating up or down. It has experienced this frictional force, and that's it. Remember, I pushed it and I let go. So the only force in the direction of motion is going to be the frictional force. So I can figure out my frictional force by multiplying my acceleration by mass. And I'll plug this in here. So this is going to be minus mass times v naught squared over 2 delta x. Well, frictional force is helpful, but what I'm trying to get to is the coefficient of kinetic friction. So I've got one more step here. So my coefficient of kinetic friction is going to be mu times the normal force, or I can rearrange this to say that my coefficient of kinetic friction is going to be divide both sides by the normal force. It's going to be my frictional force divided by the normal force. Again, it's helpful to draw a free body diagram because my normal force, well, I don't know what it is, but it's going to be equal to magnitude to mg. The direction I don't care about. It's going to be equal magnitude to mg. Right? So I'm going to plug stuff in. So I have my frictional force is minus m v naught squared over 2 delta x. I'm going to divide this by mg. notice what happens, right? So my mass cancels. Curious, right? So I didn't even need to know mass. So I'm going to have V naught squared over 2 delta x times g. So remember, I can, if I'm dividing by something, it's the same as multiplying by the inverse. So it's the same as multiplying by 1 over g, which gives me this. And now I can plug in some numbers. So this is the last thing I want to do. So yeah, if I'd given you this problem without mass, right, you might have freaked out. But oftentimes you can get mass to cancel. So sometimes you just have to start mathing your way through it and make sure it works out. So what do we give? So V naught was what, 10 meters per second. So I'm going to have 10 squared over 2 times 30 times g. I'll call that 10. So this. So this is going to be 10 over 60. Or I don't know what that comes to. So 0.166. So coefficient of kinetic friction, that seems like a reasonable value to me. So when things are sliding along surfaces, we'll get coefficients of friction between 0.2 and 0.4. And when things are stationary, the static coefficient of friction is always a little bit higher. So it seems like a reasonable value to me. So notice there are no units on this. It's just a ratio. So it's a ratio of forces, and it's just going to be a number, and that's the answer I came up with. Anyway, I hope that makes sense. Again, the connector that we use is always acceleration. So I took acceleration from here, and I connected that took acceleration from kinematics, and I connected that to forces, and the rest of it's just a little bit of math. Hope that helps. Talk to you soon. Bye.